All right, the last lecture that we're going to have for Chapter 10, States of Matter, is called Changes of State. We're going to talk about phase diagrams in this one. All right, so a phase diagram is a diagram that shows the relationship between pressure and temperature and state of a substance. And we're going to learn about all the different parts of a phase diagram. So let's go ahead and get started. So our x-axis is temperature usually, and our y-axis is pressure. So this is an example of a typical phase diagram. So in the phase diagram, you usually see three different curves. Sometimes you can have phase diagrams that only have two curves or multiple curves. This is a very typical phase diagram. So this is kind of the way that you read it. As we had mentioned before, a phase diagram is a diagram that shows the relationship between pressure, temperature, and states of matter. And where we're going to see states of matter is actually in the diagram. So let's start with our most typical substances. Usually at very, very low temperatures, we expect things to behave like a solid. So what that means is on this side, in this whole area, this whole region of space, if we have a data point of a certain pressure and a certain temperature, and it falls in this region of space, it's a solid. If it fell somewhere a low pressure and a medium temperature, and the point's right here, we expect the substance to behave like a solid. If we had a really high pressure and a low temperature, like this, we would say, okay, it's going to be a solid. But if we had something that was like a low pressure and a very high temperature, this does not fall in the solid range, so it would not be considered a solid. It would be considered something else. Moving on, the next phase is going to be liquid. So usually as we increase the temperature of a solid, we expect it to melt into a liquid. So the same thing over here. Any coordinate, any pressure and temperature coordinate that falls anywhere in this region is considered liquid. And then finally in this region of space, all this right here, this is gas. So usually the lower pressures and higher temperatures put you somewhere in a gas range. Okay, so let's just do a sample. I'll give you a couple of seconds to try and figure out. Could you tell me what state of matter a substance would be at 120 kPa and 20 degrees Celsius? Try and figure out what state of matter that might fall under. Very good. So you should have done this. You should have said, okay, 120 keeps going like this, and 20 keeps going up like that. So that is a data point right here. Okay, at 120 kPa and 20 degrees Celsius, this substance exists as a liquid. All right, let's try another data point. Let's try 80 kPa and 35 degrees Celsius. Let's see what you got. You should have landed with gas, right? Because that data point puts you right here at gas. So if you were asked what state of matter is the substance at 80 kPa and 35 degrees Celsius, you'll say gas because it falls in the gas region of space. Now here's the tricky part. What if I told you, tell me what state of matter a substance would be at 60 kPa and 20 degrees Celsius? Well, you would say, okay, I'm just going to go ahead and move along 60 like that. I'm going to do 20 up like that. I'm going to say, oh, that's very, very close to the line, but it looks like we're still in liquid phase. All right, no problem. So you get the idea. Points here, solid, liquid, gas, right? Depending on what the coordinates are. But what happens if I give you a coordinate and that puts you right here? It's on the line. What state of matter would it be? Well, now we got to start talking about what these curves actually are. So let's take a look at the three states of matter. You have solid, liquid, and gas. And think about how the particles are behaving in them. In solids, the particles are arranged in fixed positions. In liquids, the particles are still very close to each other, but they're able to move around even though they're very close to each other. In gases, the particles are very far from each other and they're moving at much greater speeds. So the first thing that we want to know is, what are the transitions called? When you go from solid to liquid, to go from solid to liquid, you need to add energy, or you need to increase the temperature. Well, it should be obvious. Going from solid to liquid is called melting. And to go from liquid to solid, you need to decrease the temperature. And decreasing the temperature of a liquid to where it gets really cold is called, well, not cold, when it turns into a solid is called freezing. Those are probably the most common phase changes that you know. But what about when you heat up a liquid so much to the point that it converts to a gas? Well, we're going to do that by increasing temperature generally, and that phase transition is called vaporization. It vaporizes, turns into vapor or gas. What about the opposite? What about when a gas gets cold enough to turn into liquid? What is that transition called? Condensation, right? So sometimes when you take a very cold drink out of the fridge, some of the water vapor that's in the air will start condensing onto the surface of your soda cans or cold drinks, even bottles. Well, that water didn't come from the inside of the can, that came from the water molecules that are in the air, and they touch the surface that's so cold that it condenses and turns into liquid. Now there's two more transitions that we're going to talk about. Going from solid to liquid, I'm sorry, not solid to liquid, solid to gas. Well, it's possible for a solid to not turn into liquid, to go straight into a gas phase. So what do you call that? Well, anyone who's gone to HEB, not like recently, but in the past, you can buy what's called dry ice. Well, dry ice is just a chunk of CO2 that's solid, but at room temperature, CO2 doesn't want to exist as a solid, so it immediately turns into a gas without liquefying, without turning into a liquid first. This phase change is called sublimation. And the opposite is possible as well. Actually, another comment for the sublimation. Anyone who's ever gone to Colorado, right, or you've seen on mountain tops from far away in pictures, and you may see like these sort of clouds coming off of mountaintops. Well, that's an example of sublimation. The pressure is so low and the temperature is low where solids can just go straight into gas phase. So the water molecules that are in the form of snow or solid water go straight into water vapor into the air. And the last phase transition that we're going to talk about is going from gas to solid. It is possible. Just like solid can go straight to gas, it's possible for gas to skip the water phase, the liquid phase, and just turn into solid. And this phase transition is called deposition. You can think of it like gas particles deposit onto a surface and turn into solid. So these are the 6 different phase changes that you are expected to know. melting, vaporization, sublimation, they all go from, in this image, left to right by increasing temperature. Freezing, condensation, deposition, they happen by decreasing the temperature. So now let's connect that to this phase diagram. It turns out that these curves represent the phase transitions. So let's start with the very first one. This curve right here separates solid from liquid. What that means is this curve is actually just a bunch of points that separate solid from liquid. Well, if solid to liquid, well, you know that going from solid to liquid is melting, and going from liquid to solid is freezing. Well, what that means is that all these points on this curve are just a bunch of melting points or freezing points. Have you ever seen an ice cube melt? Does it go straight from solid and then immediately straight to liquid? No, it doesn't. What that means is it's existing at a point where it can exist as both solid and liquid, and that's what's happening. So any point that's on the curve, the substance can actually exist as both a solid and a liquid. It's called equilibrium. So this curve is called the melting curve, or it's also called the freezing curve. It turns out that the melting point and the freezing point are the same thing. They are the temperature that separate a substance from being pure solid or pure liquid. Okay, now let's hit up the other one. Going from liquid to gas. Well, in order to go from liquid to gas, you have to pass this curve. Well, liquid to gas we know is vaporization, and gas to liquid we know is condensation. So what that means is every single one of the points that make up this curve represents the temperature and pressure at which a substance can exist as both liquid and gas. So for example, let's say we just did this. We followed a point here, and that took us here. What that would mean is that at a pressure a little bit more than 90, we'll call it 92 kPa, and a temperature of, we'll just say it's about 34 degrees Celsius, this substance will be both condensing or vaporizing, and it can exist as both liquid and gas. And now let's hit up the last one. What about going from solid to gas? Well, remember, solid to gas is called sublimation, and gas to solid is called deposition. That means that this curve that you see is just a bunch of sublimation points or deposition points, points at which a substance can exist as both solid and gas at the same time. And I forgot to name the curves. We know that this curve over here is called the vaporization curve, but it's also called what? Very good, you guessed it, the condensation curve. And the other curve over here has two names. The names are the sublimation curve and what else? Very good, you guessed it, the deposition curve. But we're still not done. We have to address a couple of more terms on here. So this, if you notice here, there's a little arrow. That means that the arrow keeps going. But if we look over here, we see a point. This point is called the critical point. What that means is we know with confidence that any value here, right, is going to give us a gas. And any value here, we know that it's going to be a liquid. What we don't know is what happens after. What happens after, at very high temperatures, and at very high pressures, this substance stops behaving like a liquid or a gas specifically. This region of space is called critical fluid, where the behavior of the particles we're unable to distinguish whether the substance is a liquid or a gas. And finally, let me ask you this. At this point right here, what state of matter would the substance be? Very good, you guessed it. All three states of matter. This is called the triple point. The triple point is the specific pressure and temperature at which a substance may coexist in all three states of matter. So you would look at your graph like this and you would say, okay, it looks like the triple point is about, say, 49 kPa, and we'll say 15 degrees Celsius by looking at your y and x axis. So that would be your triple point of this made up substance. So you're going to have to be able to look at a graph, identify where it's melting, where it's freezing, where it's vaporizing, condensing, subliming, depositing. If I give you any point, you should be able to tell me, oh, if it lands over here, it's a solid. If it lands over here, it's a liquid. If it lands over here, it's a gas. If I tell you that a substance, and I know it's kind of weird, let me see, look for the green. If I tell you that we're starting off with a substance at this point, we'll say 100 kPa and about 30 degrees Celsius, and I say we decrease the pressure to, say, 10 kPa. Well, if we have a substance and we decrease its pressure down to 10 kPa, what's going to happen? Well, this substance is going to pass the vaporization curve, and since we're going from liquid to gas, that means this substance is going to vaporize and turn into a gas. So you should be able to know that when you cross a curve, that phase change is occurring. Alright, and that's going to wrap up chapter 10. Right, so chapter 10 is going to be done. And since we're going to be done with chapter 10, that means that the next lecture is going to be on chapter 11. And since we're starting a brand new chapter, that means you have to do vocab in your composition notebook. And I'll probably be asking you to show it on Flipgrid. So, in case you're wondering, you have how many vocab terms? Oh wait, no, chapter 11. Okay, so let's see, chapter 11, you've got, let me count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 29 terms. Just kidding. 28 terms. And you have 1, 2, 3, 4, 5, 6, just kidding, 5 key equations. So that's a total of 33 things that you have to put in your composition notebook for the vocab, and you can find it on page 321. Alright, so on your Flipgrid, I'll instruct that you do have to make sure your vocab is done as well. Alright, enjoy.